Hey guys, and welcome to goBILDAtv. Today we've got a really fun episode, a lot about a few different topics actually. A big one, of course, is going to be linkages. That's going to be the name of the episode, of course. And of course, this is episode 10 of goBILDAtv. We streamed this on December 11th of 2020. So in this show, we're going to talk a lot about servo-driven and motor-driven linkages and different ways you can use those in competition robots, as well as different joints you can use to go between those different mechanisms. And we're also going to be taking a look at some new Hitec and new goBILDA products that we're going to be carrying. Great to see some of you guys in the chat. Definitely let us know. If you have any questions, feel free to tag us at goBILDAtv, and we will jump right in and get to answering those. Whew. So, linkages are one of my favorite things to design about robotics as a whole. I really love them, and they let you do a lot of really weird and really cool things. At their core, linkages are another way to transfer motion, and you can use them in a ton of different ways. One good way is to transfer one kind of rotational motion to another. You can use them to transfer a linear motion into a rotational motion, or the other way around, and overall they're just very, very flexible. And they let you do a lot of cool things. Let's see here. Hello, FTC dude, how's it going? Linkages are most common in FTC, I'd say, run by servos. This is a great example. This is a wobble goal mechanism we designed for our robot in 3 days. It runs by a servo rotating about 90 degrees from left to right, and it transfers that rotational motion into linear motion. And I think this is probably the most common method of running a linkage in FTC. You've got essentially an object that you want to travel linearly, like this slide here. And you have a servo arm that'll give you a lot of mechanical advantage. And the exact amount of mechanical advantage, so the torque to speed, or in this case, thrust to speed ratio, will change depending on where you are in the stroke. And we'll talk about that in just a few minutes here. Before that, we'll talk a little bit about our giveaway. So our giveaway for today's stream is going to be a couple of goBILDA servos. This time you guys will get to choose the ratio, so if you're going to win, or if you do win, excuse me, shoot us an email to marketing@goBILDA.com with your name, shipping address, and email, and let us know which of the 3 ratios of goBILDA servos you want. The keyword, of course, is going to be linkages, and I believe it should work in both chats today, but I could be wrong. I would not bet my life on that. Definitely, if you want to be sure to get into that, make sure to type that into the Twitch chat specifically. Let's see here. Wait, the raffle has been canceled. Yes, we did do some tests of it a little bit ago, so it may show canceled, but it should be running now, and it looks like I am getting your guys' information in as we speak. So, I suppose we'll jump right into talking about some of the new parts that we have released or are going to release while this stream is running for you guys. Alright, so the first one that we're going to be looking at is the goTube end cap. And now this is a fairly simple part. It is basically a 36mm diameter plastic part with the goBILDA pattern in it. And its primary use case is to bolt on the end of a 32mm goTube or another 32mm surface and give a surface that is a larger OD than the goTube. This is most commonly used when you're running it with bearings. So in this case, I'd be using this goTube as a shaft. And this goTube end cap is just the right size to spin freely in that bearing, just contact the outer race. And it is a really nice way to constrain the end of a piece of goTube inside of channel. That's something you can't do with something like a 32mm clamping mount or something similar. I think your goTube is smoldering. I'm not sure what you mean by that. Let's see here. no goTube connector. goTube connectors are something we have talked about, but we don't have any hard and fast plans to right now. I will think about different ways you could do that with existing parts. I feel like there's got to be a way you can do it with counterboard pattern spacers, but I can't think of anything off the top of my head. Give me a minute with that one. Let's see, what's the difference between that and a pattern spacer? It looks like untraditional brownie got that right on. It's just larger. So it'll run as, you can use it right up against a bearing to locate to act as half of the constraint necessary to run a piece of goTube. This is definitely more of a functional part that helps make goTube a better system overall, and less of like a huge amazing part. This next one that we're talking about has a lot more impact, I think, and that is a new run of Hitec servos that we're going to start carrying. They should be live really soon here. And these are Hitec Linear Servos. So this is a new linear servo Hitec has developed. They're going to be FTC legal because they're just a 5 to 8.4 volt linear servo. They come in 3 sizes, and each size has 3 different ratios. So you get either 100 mil, 50 mil, or 30 mil of stroke. And within that, you can get 50 to 1, let's see, 50 to 1, 380 to 1, or 256 to 1. 250 something to 1, I can't remember the exact ratio there, but that speed to torque ratio changes, speed to thrust ratio changes depending on the ratio that you go with and the amount of thrust that you need. These will pull about half an amp at stall, so they're definitely not a very powerful option, but they're a great option if you need to move something that doesn't necessarily have to be very fast. This is their slowest ratio, the 360 to 1, and it can definitely push a lot for its weight class and the amount of power it draws, but you can see it's really slow. It's very slow. goBILDAtv, what's the price going to be? Awesome Dude, 6,400. I believe that'll all be up on the website pretty soon here. I'm not 100% sure off the top of my head. This is a 50 to 1 right here. This is definitely a faster ratio. The wires are all black, so sometimes I plug them in the wrong way. And this is a much more reasonable ratio. You can see this is the 30 mil stroke, and it gives you definitely some room to play with. Extra battery 2, weekly Badger, witness 8mm, aluminum through bore Rex coming out. Definitely something we always talk about, so I think that would be really cool. And we actually have one up on an assembly over here that we can show you as well. So this is a piece of channel, and a nice thing about the linear servos is that the mounting brackets they come with some nice steel mounting brackets, are the goBILDA pattern. So they have M4 holes on an 8mm spacing, and they work out really well with goBILDA stuff. So I will plug this bad boy in and see how it runs. This is, I'm going to say, the most common use case for a linear servo, or a linear actuator for that matter, if you're looking at an outside of FTC application. They are really good at getting a lot of power behind a long lever arm like this. And really what we've created here is a 3-bar linkage with one of those bars able to expand. That can give you a lot of torque on this arm, and it can help be a really nice effective gear reduction on the overall length. It looks like they are also all up online right now. So you can see they can put out a pretty good amount of power, just depending on the application that you have in mind. I don't think that they're going to be a huge game changer for FTC, but I think they're a really cool thing, especially if you're looking at doing a model airplane and you want some really accurate landing retracts or something like that. Definitely let us know if you have any questions on these guys. So we're going to be carrying them on goBILDA. They're also going to be digital and programmable, so if you want to dial in the ends or change the soft start and stuff like that. How easy are these to break? I don't believe we've broken one yet. We've definitely stalled them out a few times and they've been fine. So I think they're going to be fairly reasonable. Let's kind of transition back over to linkages. Linkages are one of my favorite parts about FTC, like I talked about. I just love linkages. Really in goBILDA, you have two different scales that you can create linkages at. And those are what I call the motor scale, where you're building stuff with low side channel and powering it with a really low ratio motor, and the servo scale, where you've got beams and other small scale applications that work really well with our nylon and steel linkages. We will actually move over to our tech tips section. So, the basis of a linkage is that it's a few different mechanical bars that are all linked together and perform some task. A linkage that a lot of you guys in FTC I'm sure will recognize is the traditional classic 4-bar. This is a great example. It's made with some low side channel and dual pattern pillow blocks, and it can be really smooth. The special thing about 4 bars are that as long as the opposing bars are of equal length, they will always stay parallel. So these 2 bars here and these 2 bars here are always going to stay parallel no matter where you have this linkage. Most of the time you're going to mount one end to a robot fairly high up and have some kind of effective lift like this. You can also vary a lot of aspects of a 4-bar by varying the bar length. So if I made just this bar shorter, all of a sudden these bars wouldn't stay parallel. You would have some rotation going on throughout the stroke, and that can be really useful for some applications. A great example, if you want to dive deeper into those, are a lot of VEX lifts. They're going to be double reverse 4 bars, where you effectively stack 2 4-bar linkages on top of each other, and you get a really cool effect where your final bar in your linkage moves straight parallel up, which is very nice. Awesome Dude 6400 asks, can it be used for tilting a shooter? I would say linear servos would be a pretty good bet for that. You need a lot of precision. There are definitely other ways to do it, just like Bobby Kebab says in the chat. How do these compare to the Servo City linear actuators? So I think it depends a lot on what linear actuator you're comparing it to on Servo City. The heavy-duty linear actuators are going to be a lot different weight class. They're going to pull about 10 amps at stall, and these are going to pull about half an amp. So you're going to pull 20 times as much power, at least, because you're also going to look at a higher voltage. But if you're comparing these to the Servo City linear servos, the Actuonics linear servos, I think these are a little bit better. They're digital, and I think they can put out a little more power for what they're rated for. Sometimes, depending on what you're looking at, servos can vary a little bit on their ratings. A great example is, in my experience, Hitec ratings are pretty conservative, and something like a Savox is going to be rated right at what you'll get out of it. So even though you might have a Savox on paper that performs better, a Hitec might be able to push more power through it in the real world. So on the motor scale, linkages I think are best created with low side U channel. Just like you can see on this 4-bar here, it's a lot of low side channel, and you can either have single pieces of low side or you can stack them back to back to get a really strong I-beam shape. A great example of that is this motor-based linkage right here. It is running on a 188-to-1 motor, and it's really cool because you can get a ton of torque out of it when you're rotating an assembly. This is using another 32mm bearing to support the output shaft of this motor, so you can be pretty solid, and you can put a ton of weight on this with all of the bearing support on there. In this case, this would be a great linkage style to use to move something vertically. You could, say, fix this to a linear slide, and as you rotated this, you could push that slide up or down. This joint is a dual pattern pillow block. Those are a really fun part that we designed. They're just a collection of parts. None of these were special made for this pillow block, but it's got a thrust bearing and 2 standard bearings, so it can really, really effectively take a lot of side load and still run pretty smooth. That's what I'm using in all the joints here, and I think that turns out really, really nice. The other joint style that I make a lot when I'm building linkages on the motor scale in goBILDA is a linkage with 8 recs. So This is running just an 8mm Rex shaft with two 8mm Rex bearings that are captured by this pillow block. Excuse me. They're captured by this pattern spacer acting like a pillow block. And that can make a really smooth movement too, but it may not be quite as good at handling side load as a dual pattern pillow block, because here you've got your thrust bearing. Thrust bearings are really nice at thrust loads where you're applying a lot of load down onto that bearing, where standard radial bearings just don't handle that quite as well. I think the motor scale linkage is not something we see a whole lot in FTC, and realistically for good reason. I think it's really useful in a few cases, but it doesn't have very much broad appeal. A great example of a motor scale linkage last year was gluten-free, FTC 11115. They created a motor-based linkage to lift their double or reverse 4-bar, and that worked really, really well. The other thing about linkages on the motor scale is that you want to make sure you can start them up in a really precise place and make sure you're watching the encoder. Because most of the time you've got some pretty hard limits that you'll run up against if you are not running that correctly. On kind of the other end of the spectrum, I think the other scale of linkage in FTC for goBILDA is going to be your servo and beam linkage. And this example is really where we start seeing some really cool stuff. So servos and beams can be really, really versatile. And this is the wobble goal mechanism we created for the FTC Ultimate Goal robot in 3 days. And it's running a goBILDA speed servo. We'll actually get that up and running so you guys can see exactly how it runs. So it's pretty fast, and a lot of that speed is because of the really long lever arm that you get on this linkage system. Exactly how it's constructed is there is a beam bolted to a servo arm, and that beam is running the whole length of its first bar. That gives you a lot of speed because the length of that first arm really does have a huge effect on the effective ratio of your linkage. The second bar in this case is a linkage set. It is a ball end time joint with some threaded rod, some N4 threaded rod. These are really nice because you can really tighten down on the screws in this assembly, and the actual part will rotate on the ball bearing, or the ball, excuse me, without rotating around the screw, which means that that system can stay pretty darn tight. Whereas if I had used two beams there, I might not have quite as much rigidity. The other big advantage of this setup right here is that it gives you a lot of customization about the length of this arm right here. You can rotate this half a turn and move that whole arm length by 0.35 millimeters, so almost nothing. That can be really, really helpful if you're trying to fine-tune exactly the amount of throw you get. The other thing about a linkage like this, where you're using rotational motion to create linear motion, is that your speed and force amount vary depending on where in your stroke you are. This right here is the point where we have the most throw per degree of rotation of our servo. So this part of the linkage right here is where we hit a ton of rotation without moving the servo. We hit a ton of linear movement without moving the servo very far at all. Now, when you get out to this point right here, you can move the servo a lot more and not move the linkage, or not move this linearly very much at all. That means this fastest part of the linkage will also be the point of linkage where the servo has the least amount of force. And when you hit the ends out here, this is where you'll have the most amount of force. And this can be really nice. If you're designing a claw that has a linkage, if you design it so that these bars end up parallel, you can push on this as hard as you want, and until you snap the spline off your servo, you're not going to backdrive that servo. And that coincidentally means that servo doesn't have to work very hard at all to hold that position. Are the nylon ball linkages easy to thread? I'd say so. I've got one right here actually I can show you. The other option is our steel ball linkages. These guys are a little heavier duty. They may not move quite as freely as a nylon ball linkage, but they've got a steel threaded hole, so they thread in really easily. In this case, you can pretty much just thread it in no problem without worrying about it until it bottoms out. The nylon, you do cut your own threads, so you want to make sure you line it up correctly, and then give it a little bit of force to start out that thread. And then once you're in there, they do thread on fairly easy. My favorite thing is to grab a piece of threaded rod, just like this, and use it kind of as a T-handle, so you can stick it through that linkage and rotate it pretty easily. I think that works out really pretty well, and you get a basically already installed system. I would say for almost every application in FTC where you're using a servo to drive a mechanism, nylon is going to do it for you. It's going to cost about half as much as a steel ball link will, and it works really pretty well. Let's see here. FTC 15048 says, how many servos do you win? You win 2. 101 Bob 101. What advantage does the cup washer give? So the cup washer is just a small washer that comes with the nylon ball links. This serves to get your entire ball or linkage system back on pattern height-wise. So most of the time what I'll do is bolt that in between my ball linkage and the piece of channel. So that gives you a back on pattern dimension and is a pretty strong way to do it. Can you do the same setup for the horizontal linkage vertically? Can you attach the carriage instead of the low side and make this fixed? You definitely can, and that's actually what we did pretty much right here. I forgot the servo was on, where the carriage is stationary and the low side U channel is moving, and you can absolutely rig this up with a very similar linkage. You likely would want to use something like a torque servo so you get a little more power out of it, but something like this would work really, really well with a linkage vertically. Easy way to show you would just be to, tilt this guy all on its side. You can see it'll have kind of a problem picking up that load because it's really designed around a lot of speed compared to having a lot of torque. And you can see it has no problem moving it near the ends, but as you get to the center of that throw, it is not going to like doing a whole lot. What's the difference between the nylon shank and steel shank? I would say most applications, the steel shank is going to be probably overkill for stuff in FTC. The nylon shank is probably just fine, and most of the time I use it. Here at goBILDA, if I'm just making a linkage internally, I'm going to go with the nylon, but the steel is a great option. Generally, if you're going to pair it with the torque servo, the steel is what I think I would end up going with. Especially if you're making something vertical or something with a very long lever arm. If I was going to remake this, I think I would use steel just because it's a fairly long link, and you don't have the most mechanical advantage possible with that system. Let's see here. Definitely make sure to get in and get your entry into our giveaway in. You'll win 2 goBILDA servos of your choice if you win. Make sure to shoot us an email over to marketing@goBILDA.com and let us know your shipping address, name, email, and what servos you want to win. Let's see. Jason E says, is it just stronger? Pretty much, yeah. It's really just stronger and pre-threaded. So, if we want to, we can look a little bit more at how linear servos and other linear mechanisms tie into linkages. Because most of the time, I don't see customers using linear servos to actually move something linearly. They're actually going to want to move something rotationally and use that linear force to really get a lot of drive on that system. This is a great simple example of something you would use to say lift or tilt a shooter, or open a trapdoor in a mechanism. And it can have really a lot of power depending on your application. With this, your amount of torque that you get out of it is effectively the same way you would figure out how much torque you get out of a servo, but backwards. If you have, in this case, a 6-inch lever arm, and you're putting 1 pound of force on this, instead of having 1/6 of an ounce-inch like you would on, or an inch-pound, excuse me, like you would if you were powering the rotation, you're going to get 6 inch-pounds because you're putting that 6 pounds, that 1 pound 6 inches out. So the further out you mount that actuator, the more force you're going to get out of it. In this case, this is the faster of the Hitec Linear Servos that we offer, and it works really well when mounted about this far away, and you get a pretty nice amount of force out of it, especially if you're moving something fairly lightweight. We did not choose a winner yet, that's right. Let's see here. So, that is really the primary use case for linear servos. You can, of course, use them to move something linearly. I think within FTC, for most applications, when you are moving something linearly, they're fairly slow. So they're not going to be the greatest option. But when you're doing something like this, where you commonly need a lot of torque, this is a great way to get just a ton of torque without drawing very much power. These will run right off the expansion hub, or if you want a little more juice, you can run them off the servo power module. Contrary to a lot of servos, they're not going to draw any noticeably more current off the servo power module. But yeah. What are you using to test your servos? This is a Hitec HFP30. It's their servo programmer, and it's got some new firmware flashed on it to also be able to program these linear servos as well. It just works as a great servo tester for a lot of servos, and you can dial it into some really pretty precise microsecond level adjustments, which I like a lot. Why are the servos really expensive? They are pretty complicated little machines. They have, of course, your standard servo electronics, which are going to be pretty high quality because they are high-tech. And you're going to be looking at, in addition to that, a lead screw system and a much larger molded case. As well as overall, if you look at most linear servos out there that you can find on the market, they're going to be fairly expensive. Unfortunately, there's just a lot of components in one of these that make them fairly expensive. Is that the 3.3 millimeters per second servo? This is the fastest ratio. I believe this is 25 millimeters per second. The 3.3 we can show, it is the 380 to 1. And this one right here is in the 100 mil stroke. And this really doesn't make for very good TV. It's kind of hard to tell that it's moving, to be honest. They are very slow, but they're definitely a lot harder to stop from moving once you get them moving. Of course, in this case, you can mount this linear servo much closer to the pivot point, and you're going to move that system at the same speed. If you mounted it, say 3.8 times closer to the pivot point, you'll end up moving it at the exact same speed, and in that case, you'll require less throw from your linear servo, and your whole system can be a lot more compact. In this case, like this is the 3 centimeter linear servo, and you can mount it much closer to the pivot point and get a very similar amount of torque and speed out of your rotational mechanism as a whole, because of that much slower ratio, which gives you more thrust. How many servos will it take to lift your average shooter? All depends on the amount of weight there. You should be able to calculate it if you're looking at the, you can look at it as the same torque equation that you would use all the time. So if your shooter is mounted on a mechanism like this, the best case scenario is to use CAD to find the center of gravity, and then measure the distance between the center of rotation to the center of gravity, and that's going to be your lever arm length. And your lever arm length times your weight will give you your torque. So in this case, if that is a 6-inch arm and you have a 1 pound shooter, you're going to have 6 inch-pounds of force that you're going to need to lift up. Now in that case, you could put a 1 pound servo 6 inches from the pivot point, or you could put a 6 pound servo 1 inch from the pivot point, and require that servo to move a lot less. So it all kind of depends on exactly what your use case is. One big thing that I've seen some FTC teams do in the past that I really love is what's commonly called zero load clause, where you've got a claw system that's run by a servo, and you want that claw system to have no load on the servo while it is clamped down. This is really nice because you can use a really, really fast servo and not worry about stalling it out or burning it out. This is a great example. You can take a look at how this linkage works to get an idea of how you would implement something like this. Basically, what you're going to want to achieve is you're going to want, when your claw is clamped down on something, to have that claw, the two arms of that linkage be parallel. In this case, if you push on the end of this system, it's going to take a lot of force to be able to backdrive that servo, and that's a really, really nice application for it. Let's see. Shreep360 says, 2 years ago, one of our teams in our league used the Hitec Linear Servos to lift their robot 3 inches so their collector could go over the crater. It was cool to watch their robot extend, but there are a lot of applications for these servos. Yes, I'd say so. I think that's a really cool application if you're trying to lift a whole robot, especially not very far like that. That's a really cool example. Something similar to what 148 did, FRC 118 in 2012, I believe. It would be really cool to see out of linear servos. Is that a gecko wheel drivetrain? It is not. This is just a standard B-line with your rhinos and your Omni wheels. Somewhere around here I do have a gecko wheel drivetrain, but same as last week, you saw some unreleased parts on it, so we can't show it off quite yet. That was 8381M Robotics, I think. That would make sense. I don't remember them exactly, but I think that I do remember seeing a robot like that. That seemed really, really cool. With that, I think it's about time that we roll for our giveaway. If you guys have not either followed or typed your linkage into the chat, definitely make sure to do that right now. FTC 15048, can you saw rhino wheels in half? You should be able to. I don't think there's anything wrong with that. I don't think you can saw them because the hub would be messed up. That's possible, I would say. I can't say for sure, of course, but I would. There's nothing internally that would stop you from it. The plastic is plastic all the way through. Let's see, I think Rise did do that as well. Okay, so we'll go ahead and close our entries for this giveaway, and we'll roll for our winner. Looks like it was Carl3X. So if you're Carl3X, shoot us an email to marketing@goBILDA.com with all your info. Let us know what servo you guys would like to win, and we'll get a couple of them sent out to you. Hopefully, I suppose be a pretty early Christmas present at this point, but I think it's going to be pretty close. Speaking of that, next week's show, we're going to have a little bit more of a Christmas theme, and we're going to talk a lot about the parts that we love here, some underappreciated parts, some of our favorite parts from the year, and you can get a little more insight into what we here at R&D really love about goBILDA and what we think makes it so special. Again, congrats to our giveaway winner. When Hoax didn't win, definitely rigged drawing. It always is, I suppose. You could look at it that way. I want a Christmas present. You could definitely shoot us, if you end up ordering before Christmas, shoot me an email, and maybe they'll throw a couple stickers in your box. That'd be fun. Santa Ethan, when? I'm not sure. I think that the plan is for me to wear some kind of costume, but I don't know what it is yet. I hope it's not too bad. Glitches, I am once again asking for your 8-Rex motor support. That's funny. I think that would be really, really cool. When Hoax? I'm not sure exactly what you mean there. Let's see here. Quantum Reaver 1, oh, excuse me. It says those linear servos sound really cool. I don't know if you mean like they sound cool, like, I guess you really can't hear them, huh? Anyway, if you can hear them, I think they do sound pretty cool. They also seem like they're going to be really cool, and I'm excited to see them used on some FTC robots in the future. B-Ethan returns. I don't think I've ever worn the bee costume, so that would be a fun intro to B-Ethan. Yeah, I like the idea of them as well. I don't know. Oh, Wenhoax is, I see, it's your username. I was like, I don't know what that is. Well, let's see here. With that, definitely let us know if you guys have any more questions about linkages, about linear servos, whatever you have. Shoot us an email or give us a call. You can find us at tech@goBILDA.com and, of course, over at goBILDA.com. We're happy to help you out. You can always find me over on the FTC Discord or on the FTC Reddit. I'm Ethan goBILDA on Reddit. Let's see. goBILDA_Ethan, I think. And you can definitely find me on Discord as always. I'm Ethan D over there. Let's see here. Does goBILDA sponsor individual teams? I think that's what you're saying. Most of the time, our sponsorships are kind of prioritized, or most of our sponsorships happen at the right beginning of the season. This year, those were the Strafer chassis sponsorships, where 150 plus teams got the Strafer for 150. So that's generally going to be our sponsorship, but you can always shoot us an email. marketing@goBILDA.com is the right people to reach out to for that. Join late, but our linear servos allowed in FTC? Yes. Game Manual Part 1, all the servo rules, they're mentioned in there explicitly. These run on 5 to 8.4 volts, 4.8 to 8.4 technically. So they'll run right off the expansion hub. They pull 0.5 amps at stall, so they'll be nice to your hub electronics and all that stuff. When can we see the trike? Oh, man. Our Christmas special. We'll do that tomorrow or next week. We'll show off the trike, and you guys can see that drive around a little bit. That'll be really fun. You guys have been asking for that for a few months now, so it'll be a fun Christmas present to you guys. With that, thank you for tuning in. I hope you learned a little something about linkages and linear servos, and we'll see you next week.